right, so we're going to start off with reviewing yesterday's notes. Y'all hand wrote these. Sorry. All right, so I'm going to just go over it real quick. So our scientific notation is in this form down here. One number, one digit, decimal, as many numbers as I need to, times 10. Always times 10 to an exponent. And that exponent can be positive or negative. So we're going to look at some examples. So we are on page 8 of our journal. I want to emphasize keeping up with your journal and it matching my page numbers. Okay, so this is what we're looking at in class today. This is actually going to be cut up and put in their journal. So let's start with convert the following. So you're handwriting it into your journal unless you are printing stuff, which is perfectly fine. Following, and we're going to start with to standard form. So those of you that are printing it, when you print them, you're going to take the bottom one and glue it on this side. Okay? We will probably in class glue it this direction. Actually, I'm going to give the kids choice whatever direction they want to. All right, so number 1 is 2.8 times 10 to the 4th. All right, that 4 tells me I'm going to move my decimal 4 spots, and it's positive, so I'm going to move it to the right. So I'm going to take that decimal, and we're going to go 1, 2, 3, 4. So this number is 28,000. Okay. I'm going to box it and do number 2. 4.67 times 10 to the 6. So it's a positive exponent. Tells me I'm going to move it to the right 6 spots. So 1, 2, 3, 4, 5, 6. Plug in those zeros. 400. Sorry. 1, 2, 3, 4 zeros. Sorry, that decimal's in the wrong spot. I mean that comma. Sorry, we're at the end of the day. My brain's a little fried today. Sorry about that, guys. So we have 9.8 times 10 to the 3rd. So that 3 tells me I'm going to move my decimal 3 spots, and it's positive, so I'm going to move it to the right. 1, 2, 3. So this one is 9,800. Be sure that your commas look like commas, decimals look like decimals. I do not take off for the comma. So if you don't want to put the comma, I am perfectly okay with that. All right, so our next one, number 4, is 9.84562 times 10 to the 6th. Now, we talked about this, and I'm going to flip back to the page. In this spot can be any number, as many digits as I want. And this is a really good example. That is a lot of digits after that decimal. So let's see. So that 6 tells me I'm going to move it 6, and it's positive, so I'm going to go to the right. So write that whole number out again. 1, 2, 3, 4, 5, 6. There's actually no zeros we need to add there. All right. Let's look at number 5. Times 10 to the 7th. That is a positive 7. So I'm going to go 7 to the right. We will not always go to the right. We just happen to have a lot of positive ones in a row. 3, 4, 5, 6, 7. Notice that 7 has nothing to do with how many zeros there are. Sometimes it's going to mean, sometimes we'll have 7 zeros, and most of the time we won't, though. And I want you to go ahead and write down number 6, and I want you to try it on your own. When you have your answer, I want you to unpause this video to check to see if your answer is correct. So go ahead and pause the video, work out number 6, and see if you get it right. All right, hopefully you worked it out and got 190 also. All right, let's go ahead and look at number 7, sorry. Went ahead and wrote them down. So this is number 7, 8, number 9. Okay. So 3.5 times 10 to the negative 6. So negative tells me I'm going to go left this time, and 6 tells me I'm going to go 6 that way. So I'm going to move my decimal 6. 1, 2, 3, 4, 5, 6. Put a decimal, add zeros in those loops, and we get 0.0034535. Sorry, I was counting my zeros. All right. Notice we talked about if it is a negative exponent, my number is going to be small. And if you think about it, that is a small number. It may be long, but it's still a very small number. So let's go ahead and look at number 8. This 3 tells me I'm going to move it 3 times. Negative tells me I'm going to move it to the left. 6.2. So 1, 2, 3. So this number is 0.006382. I want you to try number 9 on your own. When you are done with number 9, so I want you to pause it, and I want you to push play when you have worked out number 9. It's really important that you practice doing these on your own for you to be sure that you're learning and understanding. Okay, hopefully you tried it on your own. So we have 8.2. We're going to go 1, 2, 3, 4. And we get 0.00082. All right, so that was on page 8. We're going to slide our journal over. In the same lesson, we never flip pages. We always just slide our journal over. And so on this page, we're going to put convert the following to scientific notation. All right, so we're going to start with number 1. And we have 5,300. Okay, so my first point is that I want a number and then a decimal. So I want a number and then that decimal. Okay, so to get there, I went 1, 2, 3. So times 10 to the third, and that was a big number, so my exponent stays positive. Remember, big numbers stay positive. So number 2, and I do like on the notes, if you looked at them, that it kind of, instead of using commas, they just kind of use the space, because the commas do get really confusing sometimes. So I'm going to move my decimal until I have just one digit to the left. And if I stopped there, I would have 5. And I only want 1. So I'm going to keep going until, see, even right there I have 2. So I'm going to go right between my 7 and 3. Times 10 to the 1, 2, 3, 4, 5, 6, 7. And that was a big number. And by big, I mean bigger than 1, but definitely a big number. So it stays positive. All right, let's look at number 3. 7,000. So again, I'm going to move my decimal to it's just one number. So it's going to be 7. I don't have to put the decimal. I don't have to put decimal 0. I can leave it just as 7 times 10. I went 3, and that is a big number, so it stays positive. All right, let's look at number 4. Still on the screen? Yes, okay. Number 4, what a unique number. So we have 4, 5, 8, 4, 5, 8, 4, 5. So when I move my decimal, remember I just want one digit, and that digit can be a 1, 2, 3, 4, 5, 6, 7, 8, 9. Can't be anything else. So if I move it there, I have all these numbers before my decimal. So I'm going to keep moving it until it's just 1. Now some of you might like it the way I did the first one, where I went ahead and put my decimal and then I counted. So this is 4.5, and I always get asked, do I have to put all of those numbers? Yes, you do, because if not, we would assume that they are zeros, and they are not. Times 10 to the 1, 2, 3, 4, 5, 6, 7. I moved it 7. It's going to stay positive, so that was a big number. Kind of went off into that second little box. That's okay. The next one's pretty small. It's really small, actually. 1, 2, 3. So I'm going to move my decimal, so that's just one number. 1, 2. So that's 1.23 times 10 to the 2. And that is a positive number, so it's going to stay positive. Now, sometimes we have a decimal already in it, like 589.85. We still want the same concept. So what I want you to do is pause at this moment, try number 6, and unpause it when you're done. All right, so I'm going to go 1, 2. So 5.8985 times 10 to the, I moved it twice, and it was a big number, bigger than 1, so it stays positive. So far, we've had all positive exponents. Sorry, I should have picked something that had more negative examples, but all right, so let's look at number 7. So there's that 0 out front if you're looking at the notes, but we don't need that 0, so I'm not going to put it because it's actually a little bit extra work. Well, not a little extra work, it just kind of looks funny. All right, so we have that number, and we want to move our decimal so that it is just one digit and then the number. So if I move it right there, that is one digit and then my decimal. So I have 6.4298 times 10. And this number was less than 1 or small. It was small relatively. If you think of it as money, it was about 64 cents. That's a small amount of money. So it is just going to be, it's going to be a negative 1. And I like that example because a lot of times we forget that exponent can be a 1. All right, let's look at number 8. So 0.00765. I'm going to move my decimal so that it is one digit. If I move it there, that one digit is 0, and it has to be 1 or greater. Nope. There we go. 7.65 times 10 to the, I moved it 1, 2, 3, and that was a small number, so it's a negative 3. For number 9, I want you to try it on your own. I'm actually going to write it a little bit lower because it's got a lot of numbers. 1, 2. We're going to have 5 zeros, 2, and then 8, 2, 4, 3. So we're going to move our decimal, okay? So I want you to pause it, try it, and when you're done, push play. Please try it. Please don't just copy the answer. Please try it. All right, hopefully you tried it by now. So I'm going to move my decimal till it's 8.243 times 10 to the, I moved it 1, 2, 3, 4, 5, 6 spots. And they were a small number, so it's negative. Remember, our form is always